So again, ladies and gentlemen, your exam will be like the review that I posted. So when you look at the review, if there's anything that I have not yet gone over, please let me know. But don't forget that we also have 2 sets of notes left, which is today and 10A and 10B. Okay? So today we're going to talk about points, lines, planes, and angles. So a point is just a point. It has 0 size. It's like a tip of the needle. Lines, there's 2 types of line. There's line with arrows on both sides. Those are infinite in length, but we still name it as AB or BA. If it's a line segment, that means it's a distance of 2 points, right? If it's a plane, it's a flat surface that has infinite length and width, but no thickness. In space, region where 3 coordinates are required for position of that space. Now again, this is also a shell, so you guys should have either already printed this out or downloaded it to your iPad, right, so that you guys can fill it in. Which, I should say, if you download it, then there's nothing to fill in yet. You're just reading as I'm reading. The dimensions of an object can be thought of as the number of independent directions in which you could move if you were on the object. Okay? Angles. When you're given an angle, it's named different ways, right? It could be named with 3 letters, where the letter in the center would be your vertex, or where the angle is, or if you label it as angle 1, or you can label it as angle B, which is the vertex. Okay? Acute angles are angles that are less than 90 degrees. Obtuse, larger than 90. And if it's 90 degrees, it's a right angle. And if it's 180 degrees, then it's called a straight angle. Are any of this a surprise to you so far? Nothing? So find the degree measure of a semicircle. How many degrees would a semicircle be? 180 degrees. Yes? How about a quarter circle? Excellent. Right? Semi means half, so you can actually do 1/2 times 360 degrees, and you'll get 180. A quarter would be 1/4 times 360, and get 90. So the word perpendicular, the symbol is this right here. And parallel is this symbol right here. Okay. So if you see those symbols, you know it's talking about parallel or perpendicular. Oh, sorry. It's the other way around. Perpendicular means it forms a right angle or a 90-degree angle. Parallel means that's equal distance from each other. With circles, you have a center. The radius is the distance from the center to the edge of the circle. And the diameter is twice the radius, or better yet, the definition of diameter is the distance from edge of the circle to the edge of the circle through the center. Polygon is closed-shaped. So what's the difference between a polygon and a regular polygon? And equal size as well. Okay. So if I was to draw a five-sided figure, right, that would still be a pentagon, right? So if I was to draw a pentagon, let's say, I can draw this as a pentagon. Right? That's still five-sided, right? So, but I wouldn't call that regular. Regular would mean that all sides and angles or interior angles are all the same. Okay. So really I couldn't even call that a pentagon, but because pentagon is actually a special name for the regular polygons. So here's the names for everything from 3 sides to 12 sides. With triangles, there's different way of classifying them, right? You can classify them by sides or by angles, right? So by sides, we have isosceles because the 2 sides are the same. Equilateral, since the word lateral means that all 3 sides are the same. A scalene is all 3 sides are all different, right? And then by angles, it's talking about an acute triangle, which means all 3 sides are less than 90. The right triangle means one of the angles is 90 degrees, and the obtuse means there's one angle that is larger than 90 degrees. Okay. Now, do you see combination of those words? Yes. You could have an obtuse isosceles triangle. Isosceles right triangle, right? So you could have those combination of words that's describing what the sides are and the angles are. Now, don't get it mistaken. If we were to mention equilateral, since all 3 sides are the same, as its angles, right, that would actually be equal angular. Because if the sides are the same, like the isosceles, the opposite angles are also the same. Okay? I don't know what I would call isosceles triangle if it's just talking about the angles. I don't think it would be isosceles angle triangle. Okay? Area and perimeter. What's the difference between area of this room and perimeter of this room? What's the area of this room and perimeter of this room?
Perimeter is just the outside of it. Area is the square footage.
So if I wanted carpet in this room, or tile, I would want to talk about the area. Right? If I want to put a pinstripe all the way around the room, then I would talk about the perimeter. And we notice the word perimeter has the word rim in it. Right? So it's the rim of the room, distance around the room. And the perimeter of a circle is called what? The circumference. Right? Now, with the circumference, you got two equations there, right? 2 pi r or pi d. On your Desmos, pi is actually a button. You don't have to approximate it to 3.14, okay? Or 22/7, okay? Only if the problem asks you guys to, then use those approximations. If not, actually use the pi key. The more decimal places you go, the more accurate your answer is. Okay? So there's some areas there, right there. So for me, I really do not like changing or having a different equation for the square compared to the rectangle, right? Because to me, it's still base times height. I hate the s squared. I think it's more important for me to remember that a square has 4 equal sides, right? And using that fact instead. Notice the trapezoid. I'm saying that side A and side B are parallel, right? You guys see that little symbol in red there? Area of a triangle and area of a circle. I think this fact is actually more important up here because it's not like I can do anything with this, right? So I should probably put this fact up here. All right, let's take a look. So the window is 4 foot by 6 foot rectangle with a semicircle on top. How much trim do I need? When I'm talking about trim, am I talking about area or perimeter? Perimeter. Okay. Awesome. So that means the total perimeter equals to the perimeter of the semicircle plus the perimeter of the rectangle, right? Okay. What's the perimeter of the semicircle going to be? What's the perimeter of a circle going to be? So let's write out the equation first. So he decided to use pi d divided by 2, right? Because it's the full circle divided by 2. Plus what's the perimeter of the rectangle going to be? is going to be 20. And you can say it by 2 length plus 2 width. Right? So from here I can say, okay, I got pi times the diameter is 4 divided by 2 plus 2 times 6 plus 2 times 4. And that's going to be approximately
Why would it be 4 twice and not just once?
as you're talking about why here and here.
No. Why is it for the perimeter, or why is it 2?
Ah. Why do I have 2 4s? Do I want the top of the circle? Do I want the top of it? No. So should I even use this? So I almost want to say that I don't even want that. I just want that, don't I? Right? And I probably don't even want to use this. What do I want to use? Now, if we're writing this out, I would just tell you to do side plus side plus side. So it'll be the 4 plus 6 plus, oh, I'm sorry. 6 plus 4 plus 6. See how easily mistakes can be made? Is good now? So that's approximately what? What is a label? Huh? Correct. Any questions there? Yes, D means diameter. Okay, how about this? This seems a lot easier, huh? Hey, since this is a triangle, area of a triangle is equal to 1/2 base times height. Is it 54? 54 what? Square feet. Do we want to talk about three-dimensional? You know what I don't have in here? I didn't give you guys links here, so I'm going to have to give you guys new notes here. Hold on. Blah, 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 blah. Wow, did I not even do those?
It's on the same page, just lower.
What?
You have it on ours?
There, I don't have the, you know what I didn't put in there for you guys? Is, the, well, this is something you guys need. So I'm going to. Ah. I do have it. You're right. You know the part that I didn't put in here? Is the perimeter stuff. So they are three-dimensional. Now, these three right here, guys, are doing the same thing. But I don't know if you guys realize it or not. Okay? So, a cylinder looks something like this. Is that right? Okay? So, when you're thinking about a volume that has something consistent. So, when you look at this cylinder, what part of this is consistent all throughout this whole cylinder? If I was to take slices and slices and slices, which part of this would stay consistent? The circle, right? Because I can just keep on slicing it, I have the same exact circle over and over and over. Agreed? So if I was to cut this really, really thin, right? Then really I only have an area of a circle. Right? If I take all those little teeny tiny thin slices of circles and stack them together, then I'll have that whole volume. Make sense? So if you look at these three, it's always the area of the consistent surface. So the area of a circle is what? Pi r squared times the height of the cylinder. So if you look at it, it's pi r squared times the height. Is the area of consistent times the height. Now look at the rectangle. Right? Length times width is the area times the height. All right? So anytime you have a shape that is consistent, it's really easy to find the volume by taking the area of what's consistent and multiplying by the height. Because if you're thinking about just taking a stack of really thin slices of that consistency and stacking it together, that would be your volume. Okay? So that's what I want you guys to realize. Sphere, however, nothing consistent, right? If I try to slice it any way, it's just going to be bigger and smaller circles. So I can't really do anything there. Do we understand surface area? So what would be a surface area of a cylinder? Because if you think about a surface area, what surface area is what or how I enclose it so that I have this, right? So the surface area for this cylinder would be if I was to take this can, cut it, and unravel it, I have a rectangle, right? And then the top of the can is a circle, which is area, surface area, and another circle. So it'll be the area of this circle plus the area of this circle plus the area of that rectangle, right? The only issue with this rectangle is this length is actually the circumference of the circle, right? So that's why you will see, and this was me trying to demonstrate what the surface area is. I'm trying to show you the front and back, the top and bottom, and then the left and right side. If I add them together, that's what we would have, okay? And then over here is a cylinder. So if I was to cut it down and open it up, you have the rectangle, you have the circle on top and bottom. So that is what the surface area would be. Everybody see that? Okay. A water reservoir has a rectangular base that measures 30 by 40. And the vertical walls 15 meters high. It was filled to capacity. At the end of the summer, the water depth was 4 meters. How much water was used? How do I go about doing that? Different kind of art there. It's okay. It's okay. It's the attempt that matters. I think in art class that was perspective art, because you're doing from one. So how much water was in there in the beginning of summer? How do I figure that out? Well, that's number one. Is knowing the fact that fill water, you're using volume. Right? Because that's where the mistakes are usually made. Right? When they fill a pool, they don't realize how much water goes in that pool. So when, shoot, I can't remember where it was. They were trying to fix a pool that was close by. Where was it? I can't remember now. And they were saying that the pool was every day. And they have no idea what. which is a lot of water, right? I mean, 10 gallons is a lot of water, but it's still, when you have no idea where it's going, it's a lot of water, right? Because 7 days later, that's 7 gallons of water. You would think it would stop at some point, right? And we're thinking too, the idea is going down the house. Because if it goes, my house is going to drop. Not good, right? So in the beginning of summer, how much volume of water did I have?
Whatever metric they're using, gallons.
So beginning of summer, volume for this is length times width times height. And you're telling me that this is 15 times 40 times 30, right? So the beginning of summer, you said, what was the number again? Is it 4,500 meters cubed? Sub E something. Is it only 4,500? I was going to say there's more than that. 18,000 you said? Because if it was just the 15 times 30, then that would be that would be 450. Yeah. Okay. We're okay there? We're good? And then at the end of summer, how much water was left? $13,000?
40 times 30 times 11.
That'd be 1,200. So 4,800? Is that right?
Yeah.
Yeah, you lost 13,000.
Yeah, I gotcha. So at the end of the summer, how much did we use? Right? You said 13,000 what? 200? Are we okay there, guys? Does that make sense? Do we know where all these numbers came from? Okay, scaling laws. So it says length scale with the scale factor. Areas is the square of the scale factor. And volume is the cube of the scale factor. So suppose that magically your size suddenly doubled. That is, your height, your width, and your depth doubled. For example, you were 5 feet tall before, now you're 10 feet tall. So you couldn't get girls before, and now you can't get girls out now either, because you're too tall now. You were too short before, and now you're too tall. By what factor does your waist size increase? So here's the thing. Length scale is with the scale factor. So if it's length, then the scale factor was double, so my length would double. If I'm talking about area, that's going to be square of the scale factor. So my scale factor was doubled, so that means my area would quadruple, 2 squared. Volume scale is cube of the scale factor. My scale factor is double, 2. So cube that will be 2 times 2 times 2, which is 8 times. Right? So it says, suppose that I doubled, that's a scale factor. So how would my waist side increase? By 2, by 4, or by 8? Waist size is just a perimeter, right? Perimeter is a length, isn't it? So that means this would double. How about the material? How much more material will you require for your clothes? Because that is surface area. Yes? Make sense? And how about your weight? It'd be 8 times.
Professor, what was the weight change?
8 times.
Okay, that was volume.
Yep. That'd be more like volume, yeah. So if you're trying to cool something quickly, do you want crushed ice or large pieces of ice? Crushed ice? Why? Why? Why does crushed ice melt faster? You're actually exposing the ice to more area, surface area. Does that make sense? Right? It's kind of like if you have a spill and I just throw this on there. It will eventually pick up the water. But if I took this and opened this up, and it's going to get wet right away, isn't it? Because I'm exposing more surface area than that. Make sense? Okay? So if you think about one big block of ice cube, right? This surface area, this surface, and that's all I got. But if I crush it, then I got a bunch of little tiny ones that have a lot of surface area. This has surface area, this has surface, this has, right? A lot more exposed. It's kind of like, so me and my brother was talking about cold plunges, right? Because that's the thing now, right? Cold plunges. In fact, I don't really, to me, cold plunges are really only good for one thing. It's doing something that sucks. It becomes mental. So that when you go through the day, When something sucks, no big deal. I was able to do a cold plunge at 34 degrees. This is not going to be harder than that. Longevity-wise, not huge things. Sauna has actually more benefits. But when we were talking about cold plunge, my brother goes, oh, you know what? Buying ice would be expensive, right? So he's like, I'm just going to go buy these bags that you're supposed to fill up and then just throw in the freezer. He goes, I would just put those in there. I'm like, that's not going to work very well. Because it's just one big bag of ice. Like, you have to leave it in there all day long for it to cool it down enough, right? But if you had a bag that fills up and then you smash it and it becomes like crushed ice and then you can pour it in there, great. It will cool down really quick. So those are the things that you guys want to think about, and that's what it talks about when it talks about large surface areas, right? Is that part right there. So we definitely want crushed ice because it gives you more exposed surface area. Is that all? I guess that's all. Any questions? So you guys know that this is on your Canvas homepage, right? And if you don't, now you do, right? Because right here, these are shells. So if I hit 10A shell, you're going to see all of this right here, right? So all you have to do is download it, print it, copy it, whatever you want to do before you come to class. All right? So 10B is right here. This is 10B. Right? So if I go to 10B, question is, do you really want to learn this today or you want to learn it on Wednesday? So what are we talking about here? We're talking about longitude and latitude, right, on a globe, right? We have degrees, we have minutes, we have seconds. So when we're talking about coordinate of a location, we have longitude and latitude. We have, again, degrees, minutes, and seconds, right? 60 seconds is in 1 minute. That's obvious. The part that is not as obvious is that there's 60 minutes in 1 degree, which you guys gotta also think about is like an hour, but it's a degree. And 1 degree is not very big. It's pretty darn small, right? And if you look at the sun typically moves, I think it's what, 15 degrees in 1 hour, about 15 degrees. So when you look, when the sun is starting to like come down, I always think about like how much sunlight we have. So I always think about, what's 15 degrees and how much time do I have, right? Because if I can do that, then at least I know I have 1 hour or 2 hours left, or nope, I don't have a lot of time left. It's time to leave the golf course, right? So those are all kind of important things there. So what I wrote up here in symbols is what I'm saying down here in words, right? So this single dash here means minutes. This double dash here means seconds. Okay? So if I was to convert 3.6 degrees into degrees, minutes, and seconds, what would I do? Well, here's the thing. It's the 3 part I'm good with, right? The 3 I know is degrees. It's the 0.6 that I got to figure out because that's a part. Make sense? That's going to break up into minutes and seconds. Make sense? Okay? So I already know that the 3 degrees, I need to break this down. So I already know 3 degrees. I need to break down to 0.6 degrees. I know that 1 degree is 60 minutes, or and should I just leave it as minutes? What does that come out to be? Does that make sense? Which part? So I'm just saying that this is equal to, right? Because I got to put them together. So I didn't do anything with the 3 degrees because 3 is already set. I know how many degrees that is. It's this partial right here that I got to convert to get the other part. Cool? Okay. Because if I convert this into minutes, I'm going to have a lot of minutes, right? Too many minutes extra, right? It's going to be like 1,800 minutes. For what reason? Why am I doing that? Because there's a lot of degrees in there. So I'm only worried about the part. All right, convert this into decimal form. So same thing. I'm not concerned about this part. This part is what it is. It's this part that's going to really be the decimal. So how am I going to convert this again? Do you want to convert it separately? Convert this separately. Because I could say, okay, let me make this and convert, oh, sorry. Take this and convert this separately. Or you want to do it together, that's certainly fine. Doesn't really matter. So how does this convert? Is that right? questions?
At what point for like degrees would you stop stop counting it? Is it like after it starts to repeat, or would the question just specify?
I would go probably two after, like, how should I say this? Because if I just say 2 decimal places, right, this would just get to 0.01, which is a lot larger than 0.0086. So I would say that like 2 decimal places with numbers. Is that fair?
Yeah.
So if you had this as 30.5586, I'm not going to mark off credit for it. I hope that you guys don't look at these and going, why is he drawing eyes up there? I just see eyes. Waiting for it to blink at me. So latitude. When the latitude is 0 degrees, it's the equator. Longitude at 0 degrees is a prime meridian. And from there, if you move up or down, it's north or south. And if we go east or west, then those are east or west. Anybody have an easy way of remembering which one is longitude, which one is latitude? Well, the problem with long is that I hope the Earth is circular. I mean, spherical, right? Really? So one was with latitude is like rungs of ladder that you climb up. When you say long, you think up and down. Interesting. I don't know if I don't know if yeah, like how I would think. Like I was hoping that long was just gonna be like, yeah, this obviously is gonna be way longer, right? But I don't know if that's the case. Throws me off. So in America, we always make a joke of, if you dig straight through the ground, you're gonna pop up in China, right? Is that true? I don't know. Let's find out. Apparently, we're gonna go with digging in Miami, though. Let's see if we end up in China. So suppose you could drill from Miami, latitude 26 degrees north, longitude 80 degrees west, straight through to the center of the Earth and continue on straight to the other side of the Earth. What is the latitude and longitude would you emerge? China. Is that a latitude, longitude? No, sir. That's a country. Any ideas? I mean, think about this. So let's say that, so this says 26 degrees north, right, on my latitude. So let's say that this is my 26 degree north. If I dug to the other side, wouldn't I be over here somewhere? Do you guys agree? Right? If I dug through the center, I'd be over there. Actually, you know what would be a better picture would be, let me try this. Because it looks like I'm going through the center, right? So do you think that this angle here, let me do it this way. Do you think that this angle here is the same as this angle here? Right? So with that being said, that means my latitude, instead of 26 degrees north, is going to be the same degree, but south. Everybody see that? Okay. Now, the 80 degrees west, right? So 80 degrees west. Oh boy, how do I do that? Oh boy. Now you're going to sit here going, oh yeah, so it must be just 80 degrees east then. Because that's what it looks like. But remember where 0 was, right? Is a prime meridian. This, however, a little bit different. So north and south is going to be the same, but instead of north, it'll be south. East and west, 180 degrees difference the other direction. That's a bad show here. It doesn't show as well. How do I want to show this? Here, let me do this really quick. Hold on. This one's hard to show. This is a lot harder to show. Try and think of what's the best way to show this. Because if I go west, I'm going this way, which the opposite would be going that way, which is 100. Like from point to point, it's still 180 degrees. But instead of going west, I'm going east. Equator is different because it just goes north and south. When it goes east and west, from prime meridian, it goes this direction. So when I go this way, the opposite side is over here, if that makes sense, right? Instead of, so if I go here, it'll be on the other side of that line. So that's the reason why it's hard to draw, because if you think about that line, going to the blue dot is here, while going to the other side, I gotta go all the way around to the other side, if that makes sense. Okay? So that's why the total is gonna be 180 degrees. Yeah? The point isn't going to matter. Like, you're not gonna have to like draw it to make it go, oh, now I see it. I only drew it so that the north and south one is pretty easy, right, to see that's on the other side. So you're not actually going to be able to picture where 26 north is and 80 degrees west is unless you have a globe and you're like, okay, so here's the longitude, here's the latitude. Okay, it's about right here. I see where Miami is, right? Then you go, okay, what's the other side? Then you got to know the center of the sphere to get to the other side. The only thing you can do is near Australia. But what you have to remember is that north and south is going to be same degrees, just flip direction. So if it's north, then it's going to be south. If it's south, then it's going to be north. With east and west, it's always going to be a different 180 degrees difference, and flip the direction. Is that fair? Okay? So it's something that you're actually going to have to remember. So it's not China? Dang it. Sorry, guys. Sorry to disappoint. Ooh. Ooh. So if you travel 1 degree latitude north or south, how far have you traveled? The circumference of Earth is 25,000 miles. So you travel 1 degree. How far did you travel? Ish. How do you get almost 70 miles?
25,000 divided by 360.
So if you think about the circumference of the Earth, it's 360 degrees, right? A full circle. So if I take so this is miles. This is degrees. So this is going to be 69.4 miles per 1 degree. So each mile that you travel, each degree you travel is going to be 69.4 miles around the Earth. But of course, this is direct, right? It's not like me driving the Ave Maria, and since I drove, 40 miles, I went 0.5 degrees. It's not that, because obviously I got roads I turn, I go north, I go south, and stuff like that. This is direct, as the planes fly, or as the birds fly. Ooh, we're going to leave this alone until next class. Any other questions for me at this time? Yes.
I saw week 3, the exam week, and it says something about
Monday, the what day is that? The 26th is Memorial Day, right? So yes, Monday of exam week is Memorial Day, so you don't have school on Monday, the 26th. So that means you guys won't have a review day before the exam. Okay? So, with that being said, that means on Wednesday, you might want to bring your review questions. So look at review 1. Bring any questions you want for Wednesday. If you don't ask any questions on Wednesday, then peace be with you. Mm-hmm. Any other questions? Nothing? All right. Ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Wednesday. Later.